According to USA Today, 62% of adults drink the milk from their cereal bowl after they have eaten the cereal. Determine if the sampling distribution would be normal if a new sample of 1,012 adults were surveyed on what they do with the milk in their cereal bowl after eating the cereal. So in this case, let's identify the sample size, which is 1,012, and the population proportion is 62% or 0.62. Now, to determine whether the distribution is normal or not, we're going to use the rule n times p times 1 minus p. If that is greater than or equal to 10, then the distribution is normal. So let's plug in the numbers. 1012 times 0.62 times 1 minus 0.62. The answer to that is equal to 283.43, which is definitely greater than 10, so the distribution is normal. And then the next question, what is the mean and the standard deviation of the sampling distribution of the sample of 1,012 random adults? This is sampling distribution of sample proportion. So the mean for the distribution of sample proportion is the population proportion, that is 0.62. And the standard deviation is equal to the square root of p times 1 minus p divided by n. If we substitute, we get 0.62 times 1 minus 0.62 divided by 1012. The answer, rounded, is going to be standard deviation. We usually round to 4 decimals, so it is 0.01526. So that is the mean and the standard deviation. Here is the mean, and here is the standard deviation. We will be using that later on. What is the probability that at most 660 adults from a sample of 1012 saying that they drink the milk from their cereal bowl after they have eaten the cereal? So notice how we have this value, which is x. So x is equal to 660, and n is equal to 1012. Since we're working with the distribution of sample proportion, the number that we have to deal with has to be p hat, which is a sample proportion. So we must compute p hat, which is 660 divided by 1012. That is x divided by n. That would be the first step. And now the answer to that, I'm going to round this to 4 decimals. So it's going to be 6522. Now, I'm going to try to sketch the problem. The mean is 0.62. 0.65 is approximately here. Now it says here, what is the probability that at most 660 adults, which is, we turned that into a proportion here. At most means the most is that, but it could be less. So it's this area right here. We need that probability. We know how to compute the probability. We're going to use norm distribution. So norm dot distribution of the area to the left of the 6522, comma the mean 0.62, comma the standard deviation 0.01526, comma true. And if you do that, if you plug that into your Excel, you're gonna get approximately 0.98251, which roughly 98.25%. And that corresponds to the correct area. I can see that visually it works. What is the probability that between 60 and 67 of the adults drink milk from their cereal bowl after they have eaten the cereal? So now we have proportions. Here is my first proportion, sample proportion. Here is my second proportion. All I need to do is to just visualize it. So here, the mean is approximately here. And then 60 is about here, 60%, and 67 is about here. 67. And we need the area in between, so we need everything in between. We're going to compute the area to the left of the big number, and then the area to the left of the small number, and then subtract them in order to find the area in between. So if we want to do that, we're going to say this is equal to norm dot distribution of 0.67, comma, the mean, comma, the standard deviation, 0.1526, comma, true, minus norm distribution of the smaller number, comma, the mean, comma, the standard deviation, comma, true. And that is going to give you, if you do that, you can do it separately and then subtract it last, or you can do it at the same, in the same cell. It doesn't really matter. So this is rounded to, I'm going to round it to 4 decimals, so 90.45, which is 90.45%. You can report this answer or both answers. It really doesn't matter which one you're going to report. So this is question number 2.